terms of robots that go into space, the sampling and caching system on the Mars 2020 mission is the most complicated, most sophisticated thing that we know how to build. This is a system that allows us to take core samples of rocky material on the surface of Mars, carefully seal them in very sterile, clean vessels for eventual return to Earth. We've been working on this sampling and caching system for 7 years, and that's because it's a tough job.
We're testing the equipment to make sure that it's going to work when we get to Mars. It has to function on its own. We have to think of all eventual possibilities and try them here first. And then if they don't work, change it now, because we can't make any changes later.
To drill into the rock on Mars, pull out intact core samples, seal them hermetically, and to be all done autonomously by a robot hanging off the end of a rover on the surface of Mars has been a challenge. We've got actually 3 robots necessary to do the sample and caching system. Our big robotic arm out on the front of the rover, that takes our drill, pushes it against the surface, and allows us to take core samples. Then we put that core sample in the bit carousel, the second robot, that takes that from the robot arm and puts it down inside our adaptive caching system. This is the part of the sample and caching system inside the rover. We've got a little tiny robot, a special robot arm called the SHAW, the sample handling arm. It takes the samples out of the bit carousel and moves them through volume assessment, image taking, and eventually to sealing, and then replaces the cylinder containing the sample in a storage spot, all on its own in the matter of a few hours. We have designs on bringing them back in a decade. Mars has been at the fore of our consciousness about the questions of life. Could life exist in one of our nearest neighbors? I think we have a lot to learn, life or no life, about the evolution of our solar system, about our planet, by looking in depth at rocks brought back from Mars.